So welcome back to part 4, and now we will look at the measurement anchor. So the first thing is to think about is when would you have an instance here in the measurement anchor, and this is an anchor that doesn't have its own keys, so it's going to have an instance here based on things in the two adjoined anchors. So whenever there's a unique combination of a player and a statistic, that is when we also get one measurement for that player and that particular statistic. So the key for this one is actually a combination of the statistic and the player. And in the source we know that the player is the key, the natural key is the name, and the natural key for the statistic is the combination of the group and detail. So all these three taken together will actually be the key for the measurement anchor. So while this framework may be smart, we will need to help it a little bit when we load this anchor. So I'm going to copy this and use that as a template and switch this to the measurement. Now we're going to do this in two passes, because the first thing we need to do is to actually create the instances here when they are missing, unless we've seen it before, of course. So then we need to create an instance, and after we've created the instance, then we can start to populate this value historically. So we're going to do a first pass here, which I will call the instance path. And now we will make use of this preparation section here. So to begin with, I want to find those unique combinations in the source. So I'm going to select from this source table. So I'm going to steal this little piece of code here, like that, and we'll call, well, we can just do a select distinct. So it's a combination of the player name, and we also have the statistic, and finally the variable. These three together constitute the key for this measurement thing. So let's just store this into something we call key for now. I suppose these were non-null values, or were they nullable? Can't remember. So let's just create unique clustered index ek key on. Just gonna create a key here so that we will speed up performance. Let's make it a little bit nicer. Oh, I forgot the table name, so I need to put that there as well. Okay, so there we have the key, and the next step now is to check which of these have we actually seen before, because they are known and we do not need to create new instances for the ones that we already know. So we're going to do a lookup, and we need to do the lookup against the adjoining tables then. So we're going to select something from the key k, and we're going to join. We're going to start by joining the player. So I'm going to use the target database and the target schema, and join the player anchor, and we're going to join it on the player name in this case, which I forgot what it was called, so I'm going to look in the player anchor here. The column name was, it had a mnemonic there, so okay, like that. And this should equal k, in which we have this player name column. So now I looked up the player. We also need to look up the statistic. So I'm going to grab that piece there, and we're going to join lst statistic, lst, and we're going to join this on 2 columns then, because there's 2 parts of that key. It's a composite key. So we're going to check here, and we have the statistics group, and this one should be equal to in the key columns was called statistic, and then we have the second part of the key here, which is just move it up a little bit. The other one, which we called detail, and in the source this was named variable, right? Yeah, like that. Okay, so now I have the now I can actually find the instances of the player and the statistics from the anchors here. But that's not enough. Now I actually have to traverse through the ties as well to get down to the actual measurement. So I'm going to continue to join here with the tie in this case. So I'm going to grab this again. Now I need to check what the ties were named. So this is the player one. PLME. On PLME dot. So in this case we want to join from the player side, and this should be equal then to the looked up identity, and we will do the same thing from the other side. I'm going to join here using the other tie from the statistic instead, which is this one, and in here you have the statistic ID. Oh, sorry, we're going to need that soon. Now I needed the name of the table, so MEST on MEST dot this, and this should equal the looked up statistic ID, like that. So now we've basically come down towards the measurement anchor from 2 directions, but that's not sufficient. We also need a condition stating now that we're actually reaching the same instance down here. So the MEST MEID should be the same as the PLME. I close that one. MEID. When those two are the same, then we're sure that we've reached the same known measurement identity in this case. So I'm going to grab the key columns, and from the doesn't matter which one, I can grab this one because they're equal. So I'm going to grab this one and call it MEID. There. So here we have now a table that will contain all of the known identities connected to these key columns that we found already. So I'm going to insert this into a table called known. Alright, so let's create an index on that one as well. And in this case, of course, we should be able to create this using the MEID column, because it should be unique, of course, because it should be only one match for each combination here. Otherwise, it wouldn't be a key. All right. So those are the 2 first steps. Now that we have this, the next step is to actually create the instances from the ones that are not known. So we can actually use this. Let's see. These are all the keys that we have in the source. and these are the ones that were known. So we can do a left join between these two to actually find the ones that are the ones that aren't known. So I'm going to do select from let's see, from key, and let's call it K, and we'll do a left join with the known ones on clustered index. Left join known on known. So these will be all of these 3 columns. So I'm gonna just paste them here. So the player names should be the same, and of course these should also be the same. Statistic equals K. And finally the variable should also be equal to K dot, like this. So, and this is of course where the known, we can grab whatever we want here, MEID is null. So we want to join here and check for the ones that didn't have a match, because these are the ones that we need to create instances for. So what I'm going to select here is MEID from, sorry, no, there won't be any, or there will they? Oh, maybe. K.MEID. This will always be null, so but the framework is smart enough, so if you try to insert null into an anchor, it's going to interpret that as you wanting to create a new instance. And we're also going to need the work ID as work ID. So these are the 2 ones that we are going to be using now. So in this case, I want to map the MEID that I have here in the source to the actual MEID in the measurement anchor. Although this is not a natural key anymore, this is actually the surrogate key. So the logic of the code that it produces is slightly different depending on whether you're using the surrogate or the natural key. So it's important to tell the framework which one you're using. All right, so this step will actually now create the instances that you have here. However, even though these instances are created, there's no way to figure out which player or statistic they belong to unless we also populate the ties here. So we can do that here in the post processing. And the first thing that I need to do is to actually find the measurement identities that I just created. And here's a good thing: this work ID is unique for this session that I'm running here, so I can I'm ensured that the identities that were created in the anchor are the ones that actually have this work ID. So I can pick them up from the anchor table. So I'm going to do that, select something from my measurement table, and I'm actually going to add this one, so it's fully qualified. So I can from this I can pick up the MEID column, and I just want to do this where the metadata column here is actually then equal to this work ID that we just said we could use. So in this case, I will pick up the ones that were just created. However, these have just been created in some random order, and it's a numerical sequence starting at some number. So what I'm going to be doing is to actually add something that we can use later on to assign these to some particular players and statistics. So I'm going to do a row number here over ordered by some column like this, and let's just name this R or whatever. So this will actually give me a numerical sequence with consecutive numbers starting from the number 1. And we need to store this somewhere as well as created, like that. Next step is to actually create a table now. Since we need to populate the ties, let's create a table in which we have assigned these to the rows that were missing the unknown rows, and the unknown rows were these ones. So I'm just gonna steal that little piece of code again, and in this case I want to join on the created, but it's not sufficient to just do that, so I'm going to have to do a little bit of a trick here. So I'm going to join. So I don't want to do that. Oh, anyway, let's just do it like this. From the key, I need also to have this R corresponding to the R, but in this case I want one number per combination that we find in that key. So I'm gonna just do star and row number here as well over, and with some ordering. So we're gonna order by, let's see if we had that list somewhere here, so I can steal this. So this will create another sequence with just as many numbers as the other one. So we can use this to join these two tables. Created C on C.R equals K.R. So this will actually assign the things that you need here. Okay, so let's see what we need from these ones. We need, of course, now it's the C, it's created ID, and we also need the do we need anything else? Yes, we do. We need all the stuff from the key one as well. So we need K. We're going to need these. And let's see if we can do something a bit smarter, like that. So we're going to put this into a table as well. Let's just call it new. Okay. So now we have, these are the ones that we haven't seen before with their assigned instance IDs that we have created already in the anchors. So now it's time to actually populate these two ties here. So let's start with the player one. Insert into. Let's grab that one. LPL player. So let's see, which columns did we have in the player anchor, player tie? There it is. So these are the columns that we need to populate. So we have the measure ID, but we don't have the player ID yet. So the thing that we need to do now is to actually select something now from this new table. But we also need to join the player table, and we had this join already earlier on here. So I can reuse that. And there was a single column that we wanted, and I changed the alias to N. So of course this will be the work ID that should be in the metadata column, and here we want the looked up identity of the player, and finally we want the measurement ID that we picked up here from the new one. So that's the first tie. Then we will do something similar here for the second tie. Coming from the other direction in towards measurement is the statistic. What? I didn't. That's wrong. It should be the tie here. Sorry for that. I'm gonna grab that one, put it there, and just delete that. I'm gonna grab this one and we'll put it there, and I will delete that. And here, oh, there was an extra sign. So this will be this one, and I'm going to put it here. And let's see what happens. So here, again, it will be the work ID, and then it will be the ME ID. There was a different ordering here of the columns. I can see it now. And then we want lst.stid from the new n and join, and we can again steal this piece of code here where we join the statistic table. So let's move back there. Of course this one should change to n and that one to n. So that should be the code for that. Then if I just install this and we move to the staging area, programmability, there will be a store procedure now. Oh, that's a leftover. I'm going to remove it. Here it is. This is the one, and if I modify this one, you can see that the code that we just wrote in the preparation section, it comes first here, and then there's a merge. Didn't like the MEID here from the key table, so I probably typed that wrong there, and some other things. So let's see what the errors are. I don't know why it's complaining about that, but there it should be a KN. It's in the section here, so I'm just going to change that like this. We regenerate the code. We can close that one. So in order for this to run, we also need to add this step here to the workflow. So I'm going to add this after that step. So this will be load measurement, and I'm going to say that this is the instance pass. So we're going to change this to measurement, and at the end here we're going to add instance, which indicates that this is the instance pass. So if we do this again, all right, so now we should be able to, if we look at the job here, maybe I need to refresh it first, and let's look at the properties of the job steps. So now you can see there's a new step here that says load measure instance, and let's do it. Let's try this. Start job at step. I'm going to start it at that step now because we've done all of the other steps previously, and we'll just wait a little while it's populating this into the measurement. It should be safe now to run this more than once, because then it will figure out that all of the ones that it created in the first run will actually be known, so it won't create any new measurements when it does that. So let's look at the current or latest measurement here. Oh, so you can see here now we have a bunch of identities and null for values, because the values will be populated in a different pause, which is the one we will be looking at now. So let's create a second pause here where we actually populate this with values. So let's copy just all of that code we just wrote, and we will remove a lot of it. And we'll do the same thing So now we we want to populate this with the actual values and the historical versions as well. So I'm just going to remove all the preps here because we did all the prepping in the previous step. Change the name of this pos to the value pos. This is arbitrary, you can name it whatever you want. We're going to write something different here. And we're not going to do any post-processing either, so I'm going to remove all of that. So here we are, ready to actually do something. So in this case, I want to select also from the source table, of course. Did I have it specified here somewhere? There. But in this case, I want all of the rows, but I want to look up, now that I know that we have instances in the measurement for everything that I need. Oh, so it's quite similar to actually this join with this one. So I can steal that join straight off and just reuse it here like this. So now I can go from the source and I can join with the player to get the player ID. I can get the statistic ID using this one. And we can get all the way down to find the actual measurement ID coming in from both directions here. So we need, in this case, one of these measurement IDs. And we will also need the date in this case, which is found in the source, because that's the date that the change occurred. So we're going to need that, and we're also of course going to need the value, because that's the thing that we're going to store in the value attribute. So we're going to keep this, but we're going to map two more columns now. So in the source we have the value column, and the target for that is, if we look at the measurement columns here, and the target is named this. I shouldn't have the brackets here, like that. And now we also need to map the historization column. So in this case it was called date in the source, and here the historization column is called changed at. And we're also going to indicate here that this is of history type. That this is a different type of column. It's not a regular value column. This is a column that captures the history of something else. All right, did we have the work ID with us? No, we didn't, so I'm going to add that as well. Work ID, that's work ID. All right, now I think we have everything we need in order to actually run this job as well. So did I save? I've saved. Let's just see if there are some errors. There were. Okay, player name. So okay, I forgot here. It should be now. It's named source. This is source. Source. All right. Okay, it runs that far. Let's also add the job step over here. So there will be a second pass, which is the value pass, and that will end with value instead. All right, so let's run this again. So if we look now at the job down here, there should be a new step here for the values, step 6. So I'm going to start the job at step 6. Start. And while this is running, I'm going to take a few minutes maybe, because it's going to iteratively now populate the values into this. So it's going to find the first version and then populate it in a loop to make sure that if we have item potency as we have, that if the same value appears twice consecutively over time, it's not going to store the second one redundantly. So I'm pressing pause for a few minutes. Okay, so the job is done, and while it was running, I actually prepared a couple of queries here. So this is just selecting 1,000 rows from the latest measurement. This is using the point in time parameterized view, so I can actually travel back to this point in time and see what it looks like back then. So just looking at these, we should at least spot some changes here. So what you can immediately see here is that, for example, here on this row, number 3 here, this value was, or is right now, 3, but it was at this point in time, because it's the same measurement ID, 1. So something has definitely changed here over time. So for example, here I also prepared a more realistic query where we start from the latest player, we move down through the ties, pick up the statistic named putts per round and the particular one which is the average putts per round. Also selecting the player here, which is Phil Mickelson, and we're looking, I'm actually joining here directly against the attribute table, so I will get all the history, because I'm interested to see that it actually has stored a history for this particular statistic. So let's just check it out. And so here we can see in descending order the putts per round for Phil Mickelson over the year and how it has changed. So following this, you can see that he started out on 27.25 and it has sort of gotten progressively worse actually up until now. Doesn't look that good. Yeah, so this was a quick example of how to build a data warehouse. I would say that we've seen some of the easier parts. This is like the player anchor, where you have the key directly on the anchor, simple attributes. We saw a slightly more complicated statistic with a composite key and a not value. And then we moved on to perhaps the most complicated thing you would ever see in an anchor model, which is an anchor in which the key in itself is not present at all on the anchor, but spread out somewhere in the model. But it won't get more difficult than that, and it won't get more easier than the player one. So that's about it. We've built a very small data warehouse that we can do some interesting analysis on now if we want. So thank you very much.